Welcome to another deep dive. You know I love getting your requests, and you guys definitely delivered with this one.
Yeah, this one's a doozy.
That's right. We're taking a deep dive into quantum mechanics. We got a submission called quantummechanics.txt, and let me tell you, someone out there is ready to go deep.
Definitely beyond the basics with this one.
Absolutely. So get ready, because we're not just going to scratch the surface.
No way.
We're going to uncover how quantum mechanics is shaping our lives right now.
The here and now.
And its mind-blowing potential to completely transform the future. I'm talking about stuff that sounds like straight-up science fiction.
Oh yeah, buckle up.
Imagine a world where teleportation is real, where you could have a chat with alternate versions of yourself.
Like having all your good and bad ideas all in one room? Could be chaotic.
Or even, and this is the big one, rewind time.
Whoa.
Back to the future.
That's right. Now, I know what you're thinking. That's impossible. That's just the stuff of movies.
Pure fantasy. But hold on to your hats, folks, because those crazy ideas, they're rooted in the seriously fascinating and very real world of quantum mechanics.
A wild ride.
It really is. Okay, first things first. Let's break down what quantum mechanics actually is. At its core, it's basically the science of the unbelievably tiny. I think particles so small, they're way smaller than atoms.
We're talking the building blocks of everything.
That's right, everything. These tiny particles are what makes up everything around us.
You, me, the chair you're sitting on, the phone you're using, all made up of those little guys.
Exactly. But here's where things get really interesting. These tiny particles, they don't exactly follow the rules we're used to in our big world. Like, imagine a ball that could be in multiple places at once.
Or a wave that suddenly decides to act like a solid object. It's like the universe is playing tricks on us.
Yeah, it's like they have their own set of rules.
And those rules are what we call quantum mechanics.
So these particles can act like waves, right?
And particles at the same time. It's mind-boggling.
Yeah, I'm trying to wrap my head around that.
They can exist in multiple places at the same time. And get this, they can even get linked up, like across huge distances. And whatever happens to one instantly affects the other.
Wait, what? So like, if one particle changes, its buddy miles away changes at the exact same time.
Yep. We call it entanglement. Spooky action at a distance.
Spooky is right. That sounds like some kind of secret, instantaneous communication method.
It's like the universe has its own hidden network, operating on principles we're only just beginning to grasp.
It's almost like quantum mechanics is the rule book for how the universe works at its most fundamental level. But this rule book, it's written in a language we're just starting to understand.
It's like we're deciphering an ancient text full of secrets waiting to be revealed.
Exactly. And speaking of deciphering, before we dive into all the mind-bending possibilities, let's give some credit to the pioneers, the rock stars, who first started cracking this quantum code.
Oh, absolutely. These are the brilliant minds that laid the foundation for everything we're talking about today.
All right, so who are these quantum pioneers?
First up, we have Max Planck. He's like the OG, the grandfather of quantum theory.
So what did Max Planck do? What's his claim to fame?
Back in 1900, he threw everyone for a loop. He proposed that energy, like light and heat, isn't this smooth, continuous flow like everyone thought.
So energy doesn't flow like a river.
Not exactly. He said it comes in tiny, distinct packets. Think of it like, instead of a flowing river, energy is like a stream of perfectly measured droplets. Each droplet a specific amount of energy.
Okay, so energy comes in these tiny packages. It's not smooth and continuous.
Right. And he called these packets quanta. That's where we get the term quantum from.
That's pretty radical for the time.
It was a revolutionary idea that changed physics forever.
So that's Max Planck. Who else is on this quantum all-star team?
Well, we can't forget Albert Einstein. He took Planck's idea of quantized energy and ran with it. He showed that light wasn't just a wave, as everyone thought. It also came in these tiny packets of energy. He called them photons.
Okay, so light isn't just a wave, it also acts like a particle.
You got it. Light is kind of a two-faced character, acting like a wave and a particle, depending on how you look at it.
That's incredible. It's like water acting like a solid and a liquid at the same time.
A great analogy. That's the kind of mind-bending stuff we're dealing with in quantum mechanics.
Okay, so we've got energy coming in packets and light acting like both a wave and a particle. What other quantum weirdness did these pioneers uncover?
Well, next up we have Niels Bohr. He took the quantum torch and ran even further with it. He developed a model of the atom. Remember those tiny electrons orbiting the nucleus?
Yeah, vaguely, from high school chemistry class.
Well, Bohr said those electrons can't just orbit anywhere. They have specific quantized energy levels, kind of like those distinct droplets of energy Planck talked about.
So electrons have designated parking spots around the atom's nucleus. They can't just park wherever they want.
Exactly. And those designated parking spots, those specific energy levels, that's what makes different atoms behave differently. It explains why gold is gold and carbon is carbon.
Okay, so Bohr's model of the atom wasn't just a theoretical concept. It had real-world implications that paved the way for the technology we use every day.
Absolutely. Without his model, we wouldn't have lasers, semiconductors, all the things that power our modern electronics.
So those lasers we use for everything from barcode scanners to laser pointers to those amazing laser light shows are all thanks to Bohr's understanding of the quantum world.
It all goes back to those quantized energy levels.
That's incredible. Okay, who else is on our quantum dream team?
Well, we can't forget Werner Heisenberg and his famous uncertainty principle. This one is a real head-scratcher.
Uncertainty principle. Sounds ominous.
He stated that you can never know both the exact position and momentum of a particle at the same time.
So it's like trying to pin down a soap bubble. The moment you think you've got it, it slips away.
The perfect analogy. It's like there's this inherent fuzziness, this uncertainty built into the fabric of the universe at the quantum level.
So no matter how hard we try, there's a fundamental limit to what we can know about these tiny particles.
Exactly. The more precisely you measure one property, the less you know about the other. It's a mind-boggling concept, but one that has been experimentally verified time and again.
So we've got these particles acting like waves, the uncertainty of their position and momentum, and light acting like both a wave and a particle. What else did these quantum pioneers uncover?
Well, we have Erwin Schrödinger, who gave us the famous wave equation.
Okay, back to waves again. I thought we were talking about particles.
That's the crazy thing about quantum mechanics. The lines get blurry. Particles can act like waves, and waves can act like particles. It's all about probabilities and possibilities.
So Schrödinger's wave equation is a mathematical tool that helps us make sense of all this quantum weirdness.
Exactly. It's a way to describe how these particles behave and predict their actions, even though those actions are inherently probabilistic.
Okay, so we've got particles acting like waves, the uncertainty of their position and momentum, and light acting like both a wave and a particle. What else did these quantum pioneers uncover?
Well, we can't leave out Paul Dirac. His work predicted the existence of something called antimatter.
Antimatter. Now that sounds like something straight out of Star Trek.
Right. But it's real. And it plays a crucial role in our understanding of the universe.
Okay, so what is antimatter exactly?
It's kind of like the evil twin of matter. Every particle has an antiparticle with the same mass, but opposite charge. And when matter and antimatter meet,
What happens? Do they explode?
they annihilate each other, releasing a burst of pure energy.
Wow. So antimatter is the stuff of science fiction, but also a very real part of our universe.
It's a perfect example of how quantum mechanics can lead to discoveries that seem like they're straight out of our wildest imaginations.
This is amazing. It's like we've just scratched the surface of this quantum world, and already it's completely changed how I think about the universe.
And we've only just begun. Wait till we dive into the mind-blowing technologies that quantum mechanics is making possible.
Okay, now you've got me hooked. I can't wait to hear about how all this quantum stuff is actually affecting our lives right now.
Let's start with quantum computing.
Okay, bring on the quantum computers.
Now, these aren't your everyday laptops. We're talking about computers that harness the strangeness of the quantum world to crunch numbers in ways that regular computers could only dream of.
Okay, so what's so special about quantum computers? What makes them different?
Well, imagine a computer that could be in multiple states at the same time. Like, it's both a 0 and a 1 simultaneously.
Wait, how is that even possible? That doesn't make sense.
That's the power of superposition, a fundamental principle in quantum mechanics. And quantum computers use it to their advantage.
Okay, so instead of processing information bit by bit like our regular computers, they're exploring all these different possibilities at once.
Precisely. They can tackle problems that would take classical computers millions of years to solve.
Whoa, so what kind of problems are we talking about?
Imagine a world where personalized medicine becomes a reality, like treatments tailored to your specific genetic makeup.
So no more one-size-fits-all medicine.
Exactly. Quantum computers could analyze your DNA and pinpoint your unique vulnerabilities, maybe even eradicating diseases like cancer before they even have a chance to take hold.
Wow, that's amazing. So we're talking about curing diseases, designing new materials with crazy properties, maybe even cracking the code of the human brain.
The possibilities are mind-boggling. And that's just the tip of the iceberg. Remember we talked about quantum communication earlier?
Yeah, the whole spooky action at a distance thing, right?
Right. We can use entanglement that connection between particles across vast distances to transmit information instantly. And I mean instantly.
Wait, faster than the speed of light. Isn't that like breaking the laws of physics?
It's not exactly breaking the laws, more like bending them. Information isn't technically traveling faster than light, but the entangled particles are connected in a way that allows for a kind of teleportation of data.
Okay, that is seriously cool. So a quantum internet, it's like a super secure, super fast version of what we have now.
Think global networks that are virtually impossible to hack. Instantaneous communication across continents, maybe even real-time language translation built right in.
So no more hackers stealing my data, no more lag on those video calls with family overseas. Sign me up.
And we're just scratching the surface here. Quantum technologies have the potential to revolutionize every aspect of our digital lives.
Okay, so we've got supercomputers and ultra-secure communication. What else is in this quantum toolbox?
Let's not forget about quantum sensing and imaging.
Okay, break it down for me. What's that all about?
Imagine clocks so precise they could measure the subtle effects of gravity on time.
What? Time is affected by gravity.
Oh yeah. Einstein's theory of relativity tells us that gravity warps time. And with quantum clocks, we could actually measure these tiny distortions.
Whoa. That's mind-blowing. So what could we use these super accurate clocks for?
Well, for one, they could revolutionize GPS. We're talking about pinpoint accuracy down to the centimeter.
No more getting lost in a new city, no more wandering around looking for that restaurant everyone's raving about.
Precisely. And in medicine, quantum sensors could detect tiny changes at the cellular level, allowing for incredibly early diagnosis of diseases. We're talking about medical imaging that can see individual molecules.
Wow, it's like having a microscopic health inspector constantly monitoring your body, catching problems before they even start.
That's a great analogy. And the potential applications go far beyond medicine and navigation. We're talking about sensing environmental changes with incredible precision, detecting minute variations in gravity, even searching for new oil and gas deposits.
It sounds like quantum sensing and imaging could revolutionize a whole range of industries. But with all this incredible potential, there must be some downsides, some challenges we need to consider, right?
You're absolutely right. It's not all sunshine and quantum rainbows. There are some serious ethical and societal implications we need to think about.
Okay, so what are some of the potential risks or downsides to all this quantum awesomeness?
Well, take quantum computing, for example. While it could solve some of humanity's biggest challenges, it could also be used for more nefarious purposes.
Like what?
Imagine someone using a quantum computer to crack the encryption methods we use today. It could disrupt global financial systems, expose sensitive personal data, even compromise national security.
So it's a double-edged sword. We need to be really careful about how we develop and use this technology.
Exactly. We need to establish ethical guidelines and regulations to ensure that these incredibly powerful tools are used responsibly.
It's like our ability to invent things is running ahead of our ability to use them wisely.
That's a pattern we see throughout history. But I believe we can learn from the past. We need to approach these quantum advancements with more awareness, more foresight.
Yeah, we don't want to create a quantum dystopia. But let's get back to the more mind-boggling predictions of quantum mechanics, things like teleportation, parallel universes, even time travel. Are those ideas really within the realm of possibility? Or are we just talking science fiction here?
The big questions. The line between science and speculation can get blurry when we're talking about these concepts. While we're still a long way off from beaming ourselves across the galaxy or hopping between dimensions, some of these seemingly outlandish ideas are grounded in legitimate scientific principles.
Okay, so let's start with teleportation. Is beaming up, like in Star Trek, really possible?
Well, quantum teleportation has been achieved on a very small scale. We've been able to teleport the quantum state of particles like photons.
Wait, so they've actually teleported particles? How does that even work?
It involves transferring the quantum state of one particle to another, essentially recreating the particle at a distant location.
So it's like copying and pasting a particle from one place to another.
It's more like transferring the information that defines the particle. And because of entanglement, this transfer can happen instantaneously.
Wow. But I'm guessing teleporting something bigger than a photon, like a person, is a whole other level of complicated.
Oh, absolutely. We're talking about manipulating trillions upon trillions of atoms with perfect precision. It might be theoretically possible, but the technological challenges are enormous.
Okay, so maybe I'll hold off on buying that teleportation travel insurance for now. But what about parallel universes? Is there any evidence that these alternate realities actually exist?
Well, the idea of parallel universes comes from a particular interpretation of quantum mechanics called the many worlds interpretation.
Many worlds interpretation. Sounds intriguing. Tell me more.
It suggests that every time a quantum measurement is made, every time there's a point where things could go one way or another, the universe splits. It creates a new branch of reality where a different outcome occurs.
So, like, every decision I make creates a whole new universe where I made a different choice.
That's the basic idea. It's a mind-boggling concept, and while there's no direct experimental evidence to prove it, some physicists believe it's the most elegant explanation for how quantum mechanics works.
So somewhere out there, there's a version of me who took that job offer, married that other person, maybe even won the lottery.
It's a fun thought experiment. But even if these parallel universes exist, accessing them or interacting with them is a whole other level of complexity. We're firmly in the realm of theoretical physics here.
Okay, so parallel universes might be out of reach for now, but what about time travel? Surely that's just science fiction, right?
Well, quantum mechanics does introduce some strange possibilities when it comes to time. For example, there's the concept of retrocausality.
Retrocausality. Sounds complicated.
It suggests that the future can influence the past, at least at the quantum level.
Wait, what? The future can affect the past. Isn't that like a paradox?
It does seem counterintuitive, but some experiments have shown that the choices we make in the present can actually affect the behavior of particles in the past.
Okay, now my brain is officially melting. So are you saying that building a time machine might not be completely out of the question?
Whoa, hold on. While these quantum phenomena hint at a strange relationship between past, present, and future, they don't necessarily provide a recipe for building a time machine. The idea of sending a person back in time still faces enormous theoretical and practical challenges.
Okay, so time travel remains firmly in the realm of speculation, for now at least, but quantum mechanics definitely opens up some mind-bending possibilities.
Absolutely. And it's not just about understanding the universe, it's about pushing the boundaries of what we thought was possible.
Well, we've covered some pretty mind-blowing concepts today, from teleportation to parallel universes to the potential for time travel. It seems like quantum mechanics is not just about understanding the universe, it's about pushing the boundaries of what we thought was possible.
That's exactly right. And there's one more area where quantum mechanics could have a profound impact: health and longevity.
Quantum-enhanced health and longevity. I'm all ears.
Imagine a world where diseases are diagnosed before they even manifest, where treatments are tailored to your unique genetic makeup, and where the aging process itself could be slowed down or even reversed.
Okay, now you're talking. That's the kind of quantum future I can get behind. But how could quantum mechanics actually lead to those kinds of breakthroughs?
Think about quantum sensors that can detect the tiniest changes at the cellular level, long before any symptoms appear. We're talking about catching diseases like cancer in their earliest stages, when they're most treatable. Imagine personalized medicine based on your unique genetic code, where treatments are designed to target your specific vulnerabilities.
It's like having a microscopic health inspector constantly monitoring your body, catching problems before they even start.
That's a great analogy. And then there's the even more radical possibility of quantum-enhanced longevity. Researchers are exploring how quantum principles might be involved in the aging process itself. Could we use this knowledge to slow down cellular decay, repair damaged DNA, or even regenerate tissues?
Wow, so we're talking about potentially adding decades, maybe even centuries, to the human lifespan. That's a game changer. But wouldn't that create a whole host of new problems? Overpopulation, resource scarcity, social upheaval?
You're absolutely right. These advances would come with profound social and economic challenges. How would we manage a world where people live for hundreds of years? What would it mean for retirement, for healthcare systems, for the very structure of our society?
It's like every answer in quantum mechanics just leads to more questions, more possibilities, more things to ponder.
That's the beauty of it, isn't it? Quantum mechanics is a journey into the unknown, a constant exploration of the universe at its most fundamental level. And while it's full of challenges, it's also brimming with possibilities that could reshape our world in ways we can only begin to imagine.
This has been an incredible journey so far. We've explored the fundamental principles of quantum mechanics, the mind-blowing technologies it's enabling, and the profound questions it raises about the nature of reality itself. But ultimately, it's not just about the science, it's about what this all means for us as human beings.
Absolutely. As we venture deeper into the quantum realm, we're not just unlocking new technological possibilities, we're unlocking new ways of thinking about ourselves, our place in the universe, and the very nature of existence.
It's clear that quantum mechanics is not just a scientific field. It's a force that's going to shape the future of humanity in profound ways. But before we wrap things up, I want to leave you with a thought-provoking question to ponder. We've explored some pretty mind-blowing possibilities today. But if you could access any quantum technology right now, what would it be and why? Would you choose the power of quantum computing, the security of quantum communication, the healing potential of quantum medicine, or maybe even the adventure of teleportation or time travel?
It's a fascinating question. It really makes you consider the potential impact of each technology, both the positive and the potential downsides.
Think about it, explore those possibilities, and let your imagination run wild. Because in the quantum world, the only limit is our understanding. Thanks for joining us on this deep dive into the fascinating world of quantum mechanics. It's been a wild ride, and we hope you've enjoyed exploring this mind-blowing subject with us. As you continue to learn about quantum mechanics, keep asking questions, keep those assumptions in check, and keep engaging in those thoughtful discussions about these advancements because they are happening whether we're ready for them or not. The future is full of unknowns, but one thing's for certain, quantum mechanics will play a huge role in shaping the world to come. So until next time, keep exploring, keep those minds open to the endless possibilities of the universe. You never know what we'll discover next.